we have this figure where we have a layer AA on which we have these molecules. These molecules are available at level AA, and we have layer BB on which we have these number of molecules. Now AA and BB molecules are moving, or these layers are moving at different velocity, because to understand viscosity we must understand under dynamic condition. Here velocity is u plus du, and this one is moving with velocity u. Now let us say these are the molecules of liquid, let us say for water. Now in case of water, if we increase the temperature, if temperature goes up, temperature is going up, in that case the attraction between these molecules, attraction between these two molecules is reduced, cohesive force is reduced. We know with the help of molecular theory that as temperature goes up, the cohesive force reduces. When cohesive force reduces, then the force of attraction of molecules BB and AA reduces. In that case what happens? The force exerted by BB to AA and AA to BB will get reduced. So it means that the resistance to the motion will get reduced, means viscosity will go down. Now if we consider second case in which we have the air or any gas. Now in case of gas, as we increase the temperature, then the molecules, they have tendency to move. In case of gases, their tendency is much higher to move from one layer to another layer and another layer to another layer, right. So this causes a momentum exchange, because these molecules, suppose this molecule is having momentum, mass of the molecule multiplied by the velocity at which it is moving. So mass multiplied by velocity, when this momentum or this molecule moves from this layer to this layer, in that case what happens? This momentum is changed, momentum this one is up by mass into velocity of this layer. Similarly, if molecule which is situated here, which is having momentum is equal to mass multiplied by velocity, velocity is equal to u plus du. So it is having more momentum when this molecules move from top level to the bottom level, which is BB. Then in this process momentum is exchange, and because of that the force is also applied. Now if we increase the temperature, then momentum exchange by changing the moment of the molecules from one layer to another layer goes up. So in that case what happens? That force applied by A to BB and BB to A also goes up. So in this manner, in case of gases, the viscosity goes up with increase in temperature. In case of water, as far as the momentum exchange is concerned, that momentum exchange always goes up, but the net effect of the change in temperature is that reduction due to the cohesive force and increase in force due to the momentum exchange. So net effect is the reduction in the force due to cohesive force, because in case of the liquid, the cohesive force is predominantly present for the viscosity. So that reduction is very high in comparison to increase in the momentum exchange. Increase in momentum will always increase the force, and reduction in momentum will always decrease the force due to momentum exchange. But in case of gases, the cohesive force predominance is less in comparison to molecular momentum exchange. Now in case of gas, if we increase the temperature, then momentum exchange goes high, and because of that the force also increased, and because of that corresponding viscosity increases.